So hi and hello. Welcome to our channel named Algo Exploration. My name is Samir and from today onwards we'll be using divide and conquer technique to solve the problem. So in today's lecture we'll be understanding divide and conquer strategies, that how to build an algorithm that follows divide and conquer technique. So let's get started. Actually, divide and conquer is nothing but dividing the problems into subproblems, then forcing the subproblems by calling them recursively until we get the subproblem's solution, and then we'll be combining the subproblem solution so that we can get our final result. So basically we have 3 points here: divide, conquer, and then combine. So let's understand by taking one example. Here we have a function that takes two parameters, low and high. You can assume low as low index and high as high index. Now, since it is a recursive code, there will be a base condition. So for time being, let's come up with the part later. After that, we have else part. Now, since we are using a divide and conquer technique, we have to first divide it. So let's say m equals to divide low comma high. So in this case, let's say if the size of the input is n, we'll be dividing into two halves, n by 2 and n by 2. In this case, we are dividing in this manner, but for other case, there will be a time that dividing will be n by 3 and 2n by 3, or it might be n by 3, n by 3, or n by 3. So dividing doesn't mean that we have to divide into two halves only. There might be condition that we have to divide in 3 parts or 4 parts or so on. So after that, we have to conquer it. That is, the solution of this problem, let's say A, the solution of this problem will be B. So A equals to low comma mid m, and B equals to m plus 1 comma high. So this is the conquer part. Now after conquer part, we have to combine it. Let's say C equals to combine A comma B, and after that we have to return the result, that is C. To the parent, return C. Now let's come to the if case, that is base condition. Here it will be always a small problem. Due to this, we call it as a base condition or a termination condition. So if small of low comma high, then we will return solution of low comma high. So that's it. In this manner, we will build the algorithm using divide and conquer technique. So now let's analyze this function. We know that the termination condition will always take order of one time. So this function will take order of one time. This function will take order of one time. So the small problem will always take order of one time. Now we don't know how much time it will take to divide the problem into subproblem. So let's say the time complexity will be f1 of n. And similarly, we don't know the time complexity to combine the subproblem's solution. So let's say this will take f2 of n. Now if this take t of n, then this line will take t of n by 2, because we are dividing into n by 2. Here also t of n by 2. So by combining these two, we'll get 2t of n by 2. Now let's see what is divide, conquer and combine. This is divide. This part is combine. And this part is conquer. And this will be the small problem. In divide and conquer technique, there will be always a small problem that will take order of 1 time. Now, t of n is equals to order of 1 if the size of the n is small, or 2t of n by 2 plus f1 of n plus f2 of n. Now this will be the size of the subproblem. This will be number of subproblem. This is nothing but time taken to divide, and this is time taken to combine. Now the both will be time taken to divide and combine at first level. So in this way, we generate an algorithm that follows divide and conquer technique. So in the next lecture, I'll be showing our first problem that follows divide and conquer technique. Thank you.